Hello everyone, this is Miss Lindsay. Today we're going to talk about section 12.1, surface area of prisms. In this unit we are going to discuss three-dimensional objects, and the first one that we're going to focus on is a prism. A prism has two parallel and congruent faces that we call bases. This is really important. Again, two parallel and congruent faces that we call the bases. So I'll highlight the first one here, which is on the bottom, and then one on the top. It is important to realize though, base does not mean bottom. We'll talk about this a little bit later in the video. The other parts of the prism, we have lateral faces. Lateral face are the parallelograms, or in other words, we kind of think of those as the sides of the prism. And again, they are formed by connecting the lateral edges. The lateral edges are these, when I'm highlighting here in green, connect all those parallelograms. If you notice, we do have what we call the lateral edge here. We have that marked as the height of the prism. It's because we're referring to our prisms as right prisms. Again, I'll talk about this a little bit more detail later in the video. Okay. So how do we classify prisms? We classify them by their bases. And again, the bases are two parallel and congruent faces. Again, extremely important. They're parallel and congruent. So if we take a look at our example on the left here, we have a triangular prism because the triangles are the two sides, the two faces that are both congruent and parallel. And the example on the right is a rectangular prism because the two sides are parallel and congruent. The lateral area of a prism is the sum of the area of the lateral faces. So in other words, we're talking about the sides. We're talking about finding the area of all the sides there. You could literally find the area, if we're talking about a rectangular prism, you could actually find the area of each of the four sides, the lateral faces, and actually add those up. We'll actually come up with a formula for that as well. The surface area is when you take the sum of the lateral area, so the area of the sides, and you add the area of the two bases. Lateral area, we usually will represent that with LA, but it's also represented with L. Surface area can be represented with a couple different things. We will do SA. I will use that most frequently. We can also use T and TA. Both of those stand for total surface area, or sometimes they just say total area. So I typically will use SA, but you will see all those notations as we go through this unit. Let's talk about how we actually would come up with a formula for the lateral area and surface area of a prism. Well, here I have a rectangular prism, okay, and specifically it is a right prism. We have H is marked as one of the lateral edges. If I just cut that prism apart right at that lateral edge and unfolded it, I would have four lateral faces, and they would unfold to form a rectangle. Okay, so to find the area, the lateral area, we definitely have one side as H, and then we have to figure out what this base is of that rectangle. Well, let's take a look. Where is this actual red mark coming from in each of the bottoms or the bases of our lateral faces? Well, if I called each side of the base 4, each part of these would match up exactly with the bottom of the lateral faces. Okay, so this actually would be equal to that entire side. The base of that rectangle would be the perimeter of the base. So to actually find the lateral area, now go ahead and refer to your formula sheet to fill these in. To find the lateral area, we would simply take P times H. P stands for the perimeter of the base. Okay, and please note on your formula sheet those are identified at the top. H is also identified as the height of the prism. And surface area, we will always identify that in terms of lateral area. So surface area of a prism, we would take the lateral area, and we know there's two bases, so we would add 2 times the area of the base. So again, B stands for area of the base. So please add those to your formula sheet. On our next part of our notes here, we have surface area of prisms and cylinders. Please notice cylinders, yes, it is on here, it describes it just a little bit. We will do that later in the unit. We are just going to focus on prisms today, okay? So let me talk about right prisms, highlight that a little bit. In our textbook, whenever they talk about a prism, they are assuming it to be a right prism. What does that mean? That means that the lateral edges will be the heights or the altitude. So as you can see here in our prism that we have the base being the pentagons. Those are the two sides, two faces that are parallel and congruent. And here the H, this would be the height of the prism because it's going to form that right angle with the base, okay? So again, right prism referring to the lateral edge is an altitude. Let's go ahead and take a look at our first example here. Whenever you're doing these types of problems, you need to ask yourself what type of figure is it and what are the bases. Okay, so in our first figure here, we know that this is a triangular prism because the two faces that are both parallel and congruent are the triangles. So this is a triangular prism. Very careful again. Base does not need bottom. If the orientation, if I drew that picture slightly different as I have done there in blue at the bottom, there it's sitting on one of the actual lateral faces. However, the two sides that are parallel and congruent are the triangles. That still represents that picture above. Okay, so they have to be parallel and congruent to be the faces. So reading the directions here, find the lateral area and surface area of each right prism. Again, right cylinders we're going to deal with later. Round your answer to the nearest tenth. So lateral area is equivalent to perimeter of the base times the height. Well, our base is our triangle here. Notice it is a 3, 4, 5 triangle, so our hypotenuse would be 10. So the perimeter of the base would be 6 plus 8 plus 10 times, again, the height. So 9 is the height of the prism. So we take that times 9, and we get that to be 216 meters squared. Surface area, we are going to take the lateral area, and again, we're going to add the area of the two bases. So lateral area is 216, and we will add the area of both bases. Well, again, each base can be different depending upon the prism. In this case, we have a right triangle, so we're looking for base and height. So we have base and height, so that is the base of the triangle and the height of the triangle. So height of the triangle. So we have the base is 8 and the height of the triangle is 6. Please notice though there is a difference between the height of the base, which we have here is 6, and the height of the prism, which would be 9. Okay. So going back to our formula here, we have 2 times the area of the base, so we have 1/2 times 8 times 6, and that would give us 264 meters squared. Let's move on to our second example. Again, ask yourselves, what are the bases here? The bases are rectangles, so this is a rectangular prism. Now, please note on this, this is going to be slightly different than the other prisms. On a rectangular base, we will use whatever the base will actually be the bottom. And again, this is only for a rectangular prism, so we will say that the 6.8 by 3.6 is our base. Okay. So again, finding our lateral area, we would have to find the perimeter of the base times the height. So we have 2 times 3.6 plus 2 times 6.8 for our perimeter. times the height of the prism, which is 2.1. Go ahead and rounding to the nearest tenth as the directions stated. We'll get 43.7 centimeters squared. To find the surface area, again, surface area, I could also use the notation TA for total surface area or total area. That would be lateral area plus the area of how many bases do we have? Well, we have 2 bases. So we'll get 43.7 plus 2 times, now we have a rectangular base, so it's just base times height, so 6.8 times 3.6, which would give us a surface area of 92.7 centimeters squared. Okay, and this concludes our notes for section 12.1.